Okay guys, so we are now discussing about velocity analysis. So velocity analysis is very useful and very important to understand in terms in kinematic machine elements. So in this chapter, we will consider the relationship of the displacement of machine part with respect to time. So first, we have to define what is the velocity. So velocity is defined as the rate um, as the rate of change of displacement of a body with respect to time. Since displacement is a vector quantity, it is represented with a magnitude and directions. So in kinematics of machine elements, uh, we are more interested with instantaneous velocity in understanding the behavior of a point at any instant or at any location of its path. So, what do you mean instantaneous velocity? In instantaneous velocity, it is the average velocity between 2 points on the path in the limit that the time between the 2 points approaches to zero. So, to more clear to understand, so we have some example for this. So considering if you have on a car, so when we're moving in a car, the speedometers show the speed at which the car is moving at that point. In at that point or at that moment, uh, in a interval, at that moment in a you kanang ganahan ka makaibaw kung unsa ang imuhang velocity at that moment. So that is referred as to instantaneous velocity. So so your car will undergo a series of changes in its speed. So we can graph that by position versus time diagram. So so I will show you. So position. So the velocity of an object under motion at a specific point of time. So we can graph the behavioral of your car or the series of changes of its speed of your car. So by position versus time diagram. So considering this figure, this is your behavioral of your uh, describing the behavioral of your car. So point A or point 1, so and point 2, yan. So at point 1, the velocity of your at instant point 1 is the slope of your curve at a specific point 1. Yan. But the average velocity between these 2 points, the point 1 and point 2, it's the slope between these 2 points. Okay? So we can say that the slope is equals to rise over run, diba? So the rise between these 2 points is the changes of your position to that between that point. So we have change of position or change of x is equals to x sub 2 minus x sub 1. And then the run is equivalent to time interval between these 2 points. Or we can say that the change of time is equals to uh, time 2 minus the time 1. So if we, by in calculus terms, so we can say that the average velocity is equals to limit of change of x over the change of time. So kanang if you kanang kung ganahan ka makakuha sa instantaneous velocity, so we have to uh, get the time approaches to 0. So time is approaches to 0. So that is a instantaneous velocity. So in a machine elements, so we are just focusing now in kanang uh, in a mechanism. So it is very important that the instant we can learn how to deal the instantaneous velocity by or in a mechanism, just like that. So in a specific point of time, so makakuha ta sa iyahang specific velocity or the instant velocity niya at uh, at a specific position po yan. So we are now moving to rotation about a fixed axis. So rotation about a fixed axis. So nganong naghisgot ani nga kani nga topic? It sa because sa kanang imuhang velocity at a point of your body is maka-create na siya og rotational about a fixed axis. So like for example, this y this body. So in this body you have or this body is denoted as S. So you have a point or a particular point to that body. So that point, or we called it point B, is subjected to velocity. Velocity. So ato sa i-define unsa na ang rotation. So rotational motion occurs if every particle in the body moves in a circle about a single line. This line is called the axis of rotation. So in this figure, the axis of rotation nato is mao ni siya. So if this point B is subjected to the velocity, so maka-create siya og rotational motion about this fixed axis. So what do you mean fixed axis? So fixed axis, we mean that the axis must be fixed relative to the body. So relative to this plane of motion. So we can create this rotational motion. Yan. So I will show you kung unsa ang pagkuha sa velocity in relation with the rotation. So considering this body, so the distance between point O to B is equivalent to R, and we have this angle theta. Okay. So I will show you the derivation of the formula in relation with the formula of velocity in relation with the rotational motion. So first we are locating the point B at relative to y in x axis. So at point B mao ni siya. So the distance between the y axis to point B is equivalent to xb is equals to r cosine theta. by your trigonometric function. So, cosine theta, the adjacent part nimo is equivalent to x sub b. And then, the hypotenuse side is equivalent to r. So, cosine theta is equals to adjacent over hypotenuse. So, we can say that your x sub b is equals to r cosine theta. And location about, the distance about point B to x-axis is equivalent to yb. So, in trigonometric function, so in the yb nimo is your opposite side. And your hypotenuse side is equivalent to r. So, sine theta is equals to yb, y sub b, or I over the r, or opposite over hypotenuse. By differentiating with respect to time, so we can say that the derivative of x sub b is equivalent to, or d sub b, dx sub b over d sub t is equals to negative r, and the derivative of cosine theta is equals to negative sine theta. And then product rule, so the theta is equivalent to uh, differentiating the theta is equivalent to d theta over dt. So the derivative of y sub b is equals to r sine theta. So here it is. So dy sub b over dt is equals to, so the derivative of sine theta is equals to cosine theta. So product rule, so the derivative of theta is equals to d theta over dt. So knowing that the omega, or the rotational motion, is equals to uh, differential theta is equals to differential time. This can be written as your, so the dxb over dt is denoted as vx, velocity bx. So we can say that the derivative of this location is the velocity of this particular point B. So we have point VBX is equals to negative R, and the d theta over dt is equals to omega sine theta. And also the dy db sub y. So we can say that your dv sub y over dt is equals to vb y is equals to r omega cosine theta. So if we get the total velocity of point B is given by vb is equals to vbx plus vby. So we can substitute the total velocity of a point B. So you can say that negative r omega sine theta plus r omega cosine theta. But atong gikuha diri is the instantaneous velocity of a particular point. So we can say that the time interval of your uh, time interval of your at that point, so approaches to zero. So your dit, or your theta, or the displacement of your angle is approaches sad sa into zero. So the cosine sine theta is equivalent to zero ni siya. So we can say that sine theta is equals to 0. So we have to cancel this equation. And the cosine theta is equivalent to 1. So ang mahibilin is VB is equals to, hence VB is equals to R omega. So we can prove that the velocity B is equals to R omega, or velocity B is equals to R times the rotational motion about an fixed axis. Now we are moving to the topic of uh, relative velocity. Relative velocity is useful in determining the instantaneous linear and angular velocity of any point in the mechanism. So what do you mean relative velocity? Relative velocity is the velocity of an object as observed from a particular reference frame or a particular point of your body, and it varies with the choice of reference frame. So consider this body y and x. So we have this body. And considering this point at A inside your body, point A and point B. So in this distance, we call it R. And we have an angle between this point. So, so if we, and I will show you on how to derive the velocity B at point B uh, relative to velocity A, or at this position of A. So first, we have to get the location of this point B. So the position of point B is given by, so we have XB from measure from Y axis. So we call it X sub B. So, and then the distance from Y axis to at point A, so we called it X sub A. So we can conclude that X sub B is equals to X sub A plus R cosine theta. So this X sub A plus this distance we have by using trigonometric function. So cosine theta is equals to uh, adjacent over hypotenuse, which is this distance over the r. So this distance is equals to r cosine theta. So add the distance from point A to this distance. So we can say that x sub b is equals to x sub a plus r cosine theta. And also we can get the position or the distance from x-axis to the point of B. So we called it y sub B. So y sub B is equals to, and and position of the distance of point A is, we called it from x-axis to point A, we called it the y sub A. So y sub B is equals to ya plus r sine theta. So ya plus this distance, which is r sine theta. Okay. By differentiating the equation with respect to time, this equation, so we can say that your x sub b or the derivative of x sub b, so mo na siya ang result. So dx sub b over dt is equals to the derivative of x sub a with respect to time, dx sub a over dt minus r, and the derivative of cosine theta is equivalent to negative sine theta. So mo nang na minus dire. So by product rule, so differentiating your theta, so d is ma-result into d theta over dt. And also the y sub b. Differentiating the y sub b, so dy b over dt is equals to dy sub a over dt plus r det theta over dt cosine theta. So if you get the total velocity at a particular point B is given by Vb plus Vbx plus Vby. By substitute your equivalent equation of Vbx and Vby, so mo ni siya. So in Vb is equals to dxa minus r dt over dt sine theta plus d Vby, which is dya over dt plus r d theta over dt cosine theta, or napani okay. So the equivalent of dxa sub a over dt is equivalent to vax, and the dya over dt is equivalent to vay minus this equation. So this d theta over dt can written as omega, which is the rotational motion. So we can say that negative r omega sine theta plus the r omega cosine theta. So mao Japon in atong gikuha diri in relative velocity v in relative to a. So atong gikuha diri is the instantaneous or the instant velocity with the time interval approaches to zero. So your theta is approaches sad into zero. So makakuha tag at a very small angle in the time interval of zero, approaches to zero. So we can say that your sine theta or sine approaches to zero is equivalent to zero. So we will cancel this equation. So ang mabilin is ang cosine theta is equivalent to 1. So ang mabilin diri is r omega. So this vex plus vey is the total velocity at point A. So we can say that your Vb is equals to Va plus R omega. So let us have an example. Example problem 1. Using graphical method, determine the instantaneous velocity of slider C of the offset slider in crank mechanism shown in the figure below. Link AB rotates at uniform angular speed of 1 rad per second in counterclockwise direction. So the dimension of your mechanism is EB equals to 20 centimeter, BC is equals to 65 centimeter, and eccentricity or E is equals to 30 centimeter. So by using your graphing paper, so we can we can locate or we can graph these dimensions or the unsay naong sa ato ang mechanism. So yan. At point A, in the figure, mao ni siya ang figure, we have 60 degrees at point A. So this is the length AB. So length AB is equivalent to 20 centimeter in actual dimension. But in your graphing paper, we have to scale about your 1 centimeter is equivalent to 1 millimeter. So in your graphing paper, you measure uh, by using your roller. So by using your roller, you measure that this 20 centimeter is equivalent to 20 millimeter. So this is the length of your length AB is equivalent to 20 millimeter at an angle of 60 degrees with along with the positive x axis. So length BC, so ano siya? So dapat ang imuhang pag-graph sa graphing paper, so dapat magka-intersect siya at point C ang E and the length BC, which is 65 centimeter in actual, but in your graphing paper we have 65 millimeter and then the E is equivalent to 30 millimeter. And the angular speed of length AB in counterclockwise direction, we have 1 rad per second. So we can say, so at the tip of velocity B, at point B, we have velocity B resulting sa kaninga omega or kaninga rotational motion. And by creating a new axis to the point B, so makakuha tag angle nga 30 degrees. So by this magnitude B, velocity B. So the direction of your velocity B or the magnitude B, velocity B, so the measure of your direction is equivalent to 30 degrees along with the negative x axis. So 60 diri. So 60. So dapat ang iyang velocity B diri is perpendicular or mo ni iyang line of action sa magnitude B. So dapat perpendicular siya into length AB, to this length AB. So we have 60 degree, so 90 minus 60, so we have 30 degrees. Okay? So kung naay rotational motion at this length AB, so maka-create sad og rotational motion at length BC. And we can say that naasay motion mahitabo sa slider at point C. By using your protractor, and we can get the velocity C and the relative velocity C relative to B. So by using your protractor, we can get the angle of your or the direction of your velocity C relative to B along with the positive x axis. So to solve this linear velocity at the tip of B, so by using the formula, V is equals to R omega, BB is equals to distance or the length of link AB times the rotational motion of link AB. So we can get the velocity at the tip of B. So 20 centimeter. No, di ni siya 20 centimeter per second. So this is 20 centimeter. So 20 centimeter times 1 rad per second. So we can get that velocity B is equals to 20 centimeter per second. So kanin siya is nasayop lang. So in a velocity scale, we can say that your 1 centimeter per second is equivalent to 1 millimeter. So the magnitude of your velocity v is equals to 20 centimeter per second. But in your graphing paper, your velocity, the length of your velocity is equivalent to 20 millimeter. So how to get the velocity c relative to b in the velocity c, or the absolute velocity c? So by choosing a convenient points, so the equation of this relative velocity is equals to velocity c is equals to velocity b, positive or negative velocity c relative to b. So by choosing a convenient point, so as denoted at q, so we have this axis. So we have to remove this velocity b, and put into this point that katong velocity. So at q, we have this 20 millimeter. So the magnitude of your velocity b at the tip of velocity b is equivalent to 20 centimeter per second, or sa graphing paper ninyo is 20 millimeter and measured by 30 degrees along with the negative x-axis. So we have to create new axis that at the end point of your velocity b, and ato sad i butang dire ang velocity c. So dapat magka-intersect siya sa velocity c relative to b. Yan. And measure by your ruler. We can say that your velocity c over b is equivalent to 75 degrees along with the positive x-axis kani at this point. And this point is a horizontal velocity, horizontal direction. So this is your velocity c. So magka-intersect na siya at that point. So makuha ninyo ang pilay measure sa velocity c over b and the velocity c sa graphing paper. And maupod na ang inyong magnitude sa inyong velocity c over b. So we can say 9.97 ako na measure sa velocity c over b, and the velocity c is equals to 15.33 millimeter. So akong velocity c over b is equals to 9.97 centimeter per second. And ako ang velocity c is equals to 15.33 centimeter per second. So the next topic is the instantaneous center of zero velocity. So this topic is another method to get uh, the value of the instant velocity at a particular point of your body. So we now solve the problem by choosing a unique reference point which momentarily has zero velocity. So the velocity of a point on a body which is subjected to a general flying motion can be determined with reference to instantaneous center of zero velocity provided the location of the instantaneous center. So consider this body. So this body is subjected to velocity at this particular point, and we call it a point A. So, so this velocity at point A, if we locate the instantaneous center, so by extending the line of action, which is perpendicular or 90 degrees to the magnitude of A, and the distance between this point A and the instantaneous center is, we call it the um, RA relative to IC, or RA, distance between A to IC. So by zero velocity, ningon man siya nga ang instantaneous center. So kung ang point nimo ang imong line of action is mapassing through to the instantaneous center, instantaneous point, so ang at that point ang imong velocity IC is equivalent to 0. And then the locus of giagian sa kaning curve, giagian sa kaning point, sa kaning point of IC nga kaning curve is, we called it the centroid. So centroid is the locus of a point which define the location of the IC during the body's motion is called that centroid. And then because this body is kanang subjected to the velocity, so maka-create pud siya og rotational motion this from A to instantaneous center. So now we have this also this figure. What if ang imuhang body is subjected to two non-parallel velocity, which so kaning point is point A and kaning velocity A and kaning point B, which is equivalent to magnitude of velocity B. So kana we can say that the magnitude of velocity for each of the arbitrary points, so kani point A and B on the body can be determined by using the equation of velocity is equals to omega r, where r is the radial distance from the IC to each point. So by locating the instantaneous center, so mao gihapon extend nato ang iyahang line of action to this kaninga velocity A and kaninga velocity B. So dapat ang iyang line of action sa kaninga duha ka points is magka-intersect. So kanang intersection points niya mao na ang iyang instantaneous center. So yan na. So, RAC and RBIC. So, dapat naka 90 degrees siya. Perpendicular to the magnitude of kana nga point. Each point. So, because this body is subject to the velocity of sa duha ka points, so maka-create pud siya og rotational motion from the IC about the fixed axis, which is locating into the instantaneous center. So we are napoy laing situation. What if your body is ano, subjected to a parallel points, subjected to a velocity in a parallel points. So from our trigonometry, so maka-use ta sa katong ratio and proportion. Mo gyapon locating the IC, so dapat ang imuhang line of action is perpendicular to velocity or the magnitude of point B and the magnitude of point A. So velocity B and the velocity A. So we have this instantaneous center. Dapat naka 90 degrees. So pwede nato magamit ang ratio and proportion. So by similar triangle. Or so the distance between IC and point A are IC, and the distance between IC to point B is RB over IC relative to IC. So napod ni, what if ug ingani mo situation sa imuhang magnitude or that point. So malocate na siya ang IC kana siya. So by using a similar triangle gihapon, so we can get the velocity point B and velocity at point A. So yan. So let us have some example, some sample problem. So this block C shown in the figure below moves with a speed of 3 meter per second. Determine the angular velocity of links BC and AB at the instant shown. So kani nga figure. So point A, we have 45 degrees. Link AB is the length is 0. meter, and point link BC, we have 0.4 meter gapon. In the slider C is 45 degrees. So at point B, the angle is 90 degrees. How can we get the angular velocity of link BC and AB? So by using the instantaneous center zero velocity. So ato na i-consider ang kaninga link. So by considering link BC, we can get the angular velocity. We have this magnitude at point C, 3 meters per second. So given na siya. Okay. So the magnitude of this point C is equals to 3 meters per second. And it is perpendicular, the line of action is perpendicular to this magnitude. So we can get the 45 degrees kana by extending this line in this velocity at point B. So extend po nato ang iyang line of action. So dapat magka-intersect siya na intersection. So at that point, mao na ang iyang instantaneous center. We can say that this angle is 45 degrees, di ba? So perpendicular man siya sa kaning magnitude, which is horizontal direction. So ang kaning angle is makuha na to, which is 90 minus 45 is equivalent to 45 gihapon. Kana. So the distance to point C to IC is equals to RCIC. Ato lang i-denote to RCIC. And maupod sa B, point B, RBIC. So pag-sum ani, which is kani is perpendicular gapon, 90, 45. So makuha na to ang angle at point IC, which is 45 degrees. And we can say, if kanang line of action nimo dapat kung passing through to the instantaneous center, so ang iyahang rotational motion diri at this perpendicular or the linear action is equal sa rotational motion to length BC and rotational motion to length CIC at this distance. So by using a trigonometric function, so tan 45, so kani, so makuha na to ang distance between these points B to IC. So tan 45 is equals to RB IC over 0.4. So which is ang kani is mao nimo ang opposite side. This is right triangle, di ba? Kani triangle is a right triangle. So this is your opposite side and this is your adjacent side. So we can get the value of or the distance of the B from B to point of IC or instantaneous center. So we have 0.4 meter. And then sa RCIC mopod, so we can get the value of the distance between C to IC by using your trigonometric function, which is cosine 45 kaning angle is equals to adjacent side over the hypotenuse side. So kaning side is the hypotenuse sa kaning triangle, this right triangle. So cosine 45 is equals to 0.4 meter is equals to R over RCIC, or RCIC is equals to 0.4 meter over cosine 45. So we can get the value of RCIC, which is 0.5657 meter. So by using the formula of the velocity in relation with the rotational motion, so VC is equals to omega BC RC times RC IC. So now we can get the rotational motion. So kay ba man ta nga ang kaninga rotational motion is equal sa kaninga rotational motion ug kaninga rotational motion. So pwede ta kanira ato ang kwaon nga rotating motion. So sa VC, we have meter per seconds over the RCIC is equivalent to 0.5657. So we can get that the omega BC is equivalent to 5.30 rad per second. So now we can get sa value at the tip or at the point of the velocity at the point of B. So we can say that the omega B IC is equivalent to 5.30 gapon. Kay equals raman ni sila ang tulo, di ba? So 5.30 rad per second gapon ang omega B IC. So consider na sa kaninga ba kuan kaninga link point link AB, we have 0.4 meter. So ang imuhang velocity B times omega B over IC times RB over IC. So we can say that velocity B is equals to 5.30 times 0.4 meter. So velocity B at point of B is equals to 2.12 meters per second. And makuha sad nato ang iyahang omega or the rotating motion at this link AB. So 2.12 meters per second over 0.4 meter is equals to 5.30 rad per second. So that's all and have a good day.